All right. Good morning, good afternoon, and good evening. Good soul to everyone from around the world. I hope you can hear me. Thank you all for joining me today. I'm Arvin Joseph Tan from Habitat Marte, and I'm an electrical engineer, currently doing my master's thesis on satellite or CubeSats to be exact. And today I will be presenting to you a short study that we made on the sustainability of operations of a power generation facility on Mars. So, um, okay. Literature on the technologies that enable Mars missions are numerous. However, the operations and maintenance of these technologies also needs to be addressed, especially in the context of Martian environment. And sustainability is a major consideration for any future crewed Mars mission. So in this study, we attempt to explore the sustainability of operations and maintenance of said facility. And this paper was, this study was conducted in Habitat Marte last July. So maybe you ask, what is Habitat Marte? It is a Mars analog research station in Brazil that started just last year. However, because of the pandemic, all the missions were conducted virtually since April. And I was a part of three of those missions. And in one of those missions, we decided to tackle the problem of power generation and the sustainability of such. So what do we mean by sustainability? How do we quantify this term? So for us, we ask how much time and supplies will the crew spend on the operations and maintenance of such facility? And to further break down the issue, we had some scenarios that we discussed. And in one of the scenarios, the facility was placed in an equatorial region of Mars. So to be specific, Planitia. And the assumption was that it is around winter time, so dust storms are more prevalent and it's dustier. And for the architecture of the facility, we decided to make a hybrid architecture. So the primary source would be kilopower nuclear, and the secondary would be solar panels. Um, we decided to include kilopower because it's very promising at the moment, and it's a very popular candidate among the different power sources. And it seems NASA will be pushing on with this power source. And however, we all know that the solar array or the solar panel is a more mature technology in terms of implementation on Mars. We have already had several rovers that use this. And however, for this study, I would just be focusing on the solar array operation and maintenance because the literature on this is plentier. It has much more compared to kilopower. And yeah, I'm just going to pass over this slide. And just to give you a clearer picture of how we want to see that, how we envision the facility, it's more of a hybrid, as I mentioned. So you can see on the left the solar array, and then on the right the nuclear segment, and they are connected through a distribution line that is transmitted or distributed to the other facilities. And the inspiration for this concept is, if you're familiar with the cell tower concept or the cell tower implementation, wherein the cell towers are isolated and then semi or very autonomous. So that way the facility is running by itself or almost running by itself, but the crew can proceed and just visit the site whenever they need. I'm sorry, I think there's an echo. Um, yeah, so to proceed with the operations and maintenance. Yeah, so this is one of the. Sorry, I think there's an echo from one of the participants. I can anyway. Um, Carrie?
Yes, I'm not sure where that's coming from.
I'm seeing it's from Lores.
Yes, I'd ask you please. Hey, Lawrence, Jesse, can you please mute your microphone and stop your stop your video, please?
I'll do it.
Hello. There's a strong feedback. Should I proceed, Carrie, or?
Yeah, I'm trying to hear it, but Lawrence, Jesse, please mute your microphone and turn off your video.
Harry, as host, you can mute your microphone.
I don't know what the hell that was all about.
Hello. Okay, I think it's done. Yeah, continuing. Yeah, so this is this slide. You can see one of the implementations, one of the visualizations that we did in Mission 47, one of the missions, and this was implemented by the architect Yash Ratod. And just to a quick visualization, you can see here the nuclear segment on the left, and then the solar array on the right, on the bottom. And this is one of the visualizations that we imagined. But before we proceed, I need to review some basic concepts about maintenance and the operations. So, according to some literatures, these are some of the main categories for maintenance. So, this will be the outline for my presentation with regards to this aspect. So, I will be discussing some preventative maintenance, corrective maintenance, and just mention some predictive maintenance. And before I continue, because if you can see in the previous slide, I will be talking about one of the primary concerns with regards to solar array maintenance is the cleaning of the panels and the routine inspection. So we need to understand the Martian environment, especially the dust effects on the potential dust effects. So one of the peculiarities about Martian dust, is that it is very fine, about less than a micrometer, and they tend to when they're deposited on the surface, they tend to uh, create some layers. So it's not just one layer; it's just multi layers. And however, as we've seen with solar arrays on rovers, the adherence of dust to solar arrays is weak, especially when they're very heavy, when they tend to have a heavy loading. So we've seen some episodes on the rovers that despite them being very dirty with dust, after a dust storm or a dust devil passes by, the panels are clean again, although not 100% clean, but they're relatively clean. And
Martha, come here. I need your help.
however, during some simulations with in other papers, they mentioned that despite
I'll show you.
benefit of weak adherence of dust, they noticed that the lower levels of dust still need to have some very strong winds just to remove. So yeah, yes, you can clean the higher layers, but there's still one or two layers of dust that remains. And so this brings me to my point, that in the operations and maintenance of solar panels, of the solar power plant, there still needs to be some manual cleaning to remove the dust, or some mechanical cleaning. And there's already literature on electric dust removal. However, those literatures also mention that there's still a need for the mechanical aspect. And then one more thing, regards to the electric removal, there's still the question of long-term performance of these dust shields in the Martian environment. So just to give an example of the electric dust removal systems that I mentioned, on the left you can see on the right, sorry, on the right you can see the electrostatic removal system from Callier et al. I hope I'm saying his name correctly. And on the left, you can see the recent design for Earth-based solar plants. So the left is for Earth-based, and the right is for Mars-based. However, you can see that especially on the right, you can see that even though the electric system can remove the dust on top of the specified area, however, the dust is still on the margin, on the fringes. So there will be a task to mechanically remove this dust on the fringes. And as of now, we have yet to see some commercial panels that already have this integrated in them. And so this brings me to a second point about about the maintenance and of the solar plant. And this aspect was inspired by just a shout out to my colleague Ben Smith. I think he's here in the audience. He will also be presenting tomorrow about his spore concept. So I'm thinking, yes, we need to be high tech about about most of the stuff that we bring on Mars, but for smaller settlements, for example, I'm giving here an example on Tatooine, if you're familiar with that, Star Wars. And probably for smaller settlements, we can do with less high-tech stuff. So there could be some merit to this. And I'll introduce more data on this or research. We reviewed some papers about cleaning panels. So there are several literature about this. And then we found some papers on cleaning the panels in a dust environment, in the context of a dust environment. So I'm showing here the result of two papers from one from Middle East and then the other from South Africa, and they suggest that the cleaning frequency for the panels would be around 1 to 2 weeks, and then this can be done with microfiber wipes. And the graph I'm showing at the bottom is my calculation. So I'm not gonna give you more of the data. You can ask me later. But what you can see here is that as you increase the crew size from 1 person to 4, you can reduce the man hours needed per person to clean the panels. And this is I'm assuming that the power plant is the capacity is around 60 to 200 kilowatts. And I think this is about 1,000 to 5,000 or 6,000 panels in the range. And you can see that this is per, let's say, per day. And if you can stretch that out to 2 to 3 days, it looks kind of practical, feasible. It's possible to do the manual cleaning. But the other question now would be, how safe would it be for the crew to be spending so much time outside of the habitat, outside the radiation shielding? And another aspect of that exposure to the elements for the maintenance would be, according to literature as well on the Earth-based solar plants, some of the systems need to be monitored and need to be maintained during the course of the plant's life cycle. And one of the most or the least reliable um, subsystems of that plant are the inverters. So for the non-electrical of the people in the audience, inverters are the main subsystem for converting the DC power to AC for our AC needs. So what I'm trying to paint the picture, or what picture am I trying to paint here? It's that there will be a need for the crew to inspect these subsystems manually, and then even replace the subsystems themselves. And in the context of a dusty environment, this needs to be addressed. How do you open boxes in the presence of very fine dust? And not only that, there are also a lot of different tasks that can be done, that have to be done in the context of a solar plant. And then you can see here, there's a long list of maintenance checklists. And these are from the sources are from I got this from the U.S. Department of Energy, and then the other ones from a private commercial company. And you can see there are so many things to check. So the issue here would be, how do you address that need to physically test the subsystems in a dusty environment. And this part is just to reiterate the point, as I mentioned earlier. If you can remember, the facility is isolated in a way from the main habitat, and that if crew, or if the crew will be visiting the site for several days to do the maintenance, then there needs to be a life support system that will address that issue. They can't just bring the supplies every time they go there. It has to be there. And one way of doing this probably is to have a small greenhouse attached to the power plant facility, so that it addresses that issue. And one way of having that system also is to have automated automation and robotics to handle the stresses of manual labor, especially in that context. And so to conclude, what are some of the suggestions that can be achieved from this short study? Is that I think there's a need for more research on the operations and maintenance of these power plants, especially the solar plants. And we need to also address that yes, we can have the manual setup. We can have people visiting the sites, doing the extended checkups. However, we need to because we're already doing this anyway on Earth analogs. However, there's a need to think about this in the context of spacesuits, of the crew wearing spacesuits in restrictive suits, and then how will it affect them physically, psychologically, as you do it in a longer period of time. And so this is also, I want to also highlight the need for predictive monitoring systems in this context, because if you can reduce the amount of time for the crew to be visiting that site by having the system automatically monitoring it, then that would be great. And showing my last slide.
5-minute warning.
Oh yeah, so this is my last slide. I'm just going to highlight some points. There's a need for predictive maintenance, especially in the context of the monitoring. And if we can make it the fault detections automated as well, that would really help the crew. And the systems have to be understood in the context of the Martian environment. We can't just put our mature systems on Mars, because we need to understand how they will interact with the radiation, with the dust. And there's also a strong need for automation to reduce the workload for the crew, because it will really help. For example, if it's a scientific expedition, then that would really help. But if it's just highlight on the last part, if it's more of a homesteading, then I think there's a potential for having less technical, less high-tech solutions to operations and maintenance of these facilities. And that ends my presentation. Thank you all for listening. If you're interested to know more about our research station that we have, Habitat Marte, you can visit the site. Or if you want to contact more, to discuss more the topics that I mentioned today, you can find me on LinkedIn, or you can also find me on the Slack, Mars Society Slack. Thank you.
Thank you so much. And I'm going to go ahead and let our volunteer Lee ask some of the questions that are in the chat right now. I'll be leaving this call to go start our next call, but you will be able to be in this call till about 3:40. So you have actually about 15-20 minutes for question and answer if you would like. Lee, go ahead.
All right, great job, Arvin. Thank you for your presentation.
Thank you.
So we have a few questions here so far. Folks, if you have any questions for Arvin, please put them in the chat and I'll ask them. First of all, Richard asks, would a solar-powered compressed gas system work most effectively, for example, grabbing carbon dioxide from the local atmosphere to blast a gas layer across the panels once a day or so for cleaning?
Yeah, that's a good question. Thank you for that. Yes, in the literature, it was mentioned that you can also use compressed gas to clean the dust. However, the problem, I'm just thinking right now, one of the issues about blowing dust around in the context of low gravity and then environment on Mars is that the dust takes takes a long time to settle down. So I think it will blow away. It will address the issue of dust on the panels, but I think it will be more problematic in that it's going to redistribute some of the dust around. Now, I can't speak definitively on this, but it would be nice to have this in a simulated environment. And I think this is one task or one research that can be done by um, analog stations around the world. I think they're perfect for this kind of testing. I hope I addressed that issue. Thank you.
Thanks. Ben asks, how about just using DC for the settlement and getting rid of the AC headaches altogether? Can you speak to the benefits of AC versus DC?
Oh yeah, that's that's one of the basic questions that it's really pushed around regarding these implementations. Thank you for that, Ben. Yes, we can, but I'm thinking about this. Our thinking about this in the long term would be, on Earth we're still using AC a lot. So if you want to have, let's say, if you want to have tourists probably or people migrating from Earth to Mars, then they would be bringing a lot of AC electronics with them. For example, just phones, laptops. Unless we can address those, that maybe they can bring their own converters. But I think it for at least for the short term, we would have to think about in the context of DC-AC conversion, inversion. But I don't know, who knows, because we already know that okay, I don't want to talk too much about the issue of DC or AC generation, but we already know it has already been established that the AC is in terms of transmission is more efficient compared to DC transmission. But that's talking about high voltage stuff. And for this kind of setups, let's say the small settlements or household, we usually won't need high voltage stuff, but yeah, probably in the case of household and then tourists coming in, then I think we still have to consider uh, DCAC. But just to add a quick point to that, um, we know that there are small inverters that we use on cars, and I think if we can address the issue efficiently of DC AC inversion in the power plant level, then I think we can address it on a smaller scale in terms of people just bringing their own DC AC inverters. I hope I addressed that point.
Yeah, thanks. Definitely benefits and drawbacks to each. Inara and Richard both ask about collecting solar power in open space and then transmitting it to the surface using microwave beams to antennas on the ground.
Yes, there's also this implementation of solar power is more of a long-term solution. It will address most of the issues on surface power, surface solar power. However, the problem with that right now is we still have to see an implementation of solar-based power in the scale of kilowatts. So yes, it will happen in the long term. Because from the literature I've read about solar microwave transmission, the rectenna, the antenna they use for this kind of transmission is more robust to dust, to dusty environment compared to the solar panel. So yes, this will be great if we can have this solar-based power, and I think there are so many literature on this. The problem is the implementation, the engineering implementation, though. So there's that.
The only other question I see in here right now is from ET. He asks, are there lots of dust storms on Mars? Does it have a weather system to create wind and dust storms?
Yes, thank you for that question. I was just reminded of a point that I wanted to make in the presentation. Dust storms on Mars are, I mean, the global scale dust storms on Mars are, you can count them by hand. They only happen around winter time. And I think if I'm correct, about 2 or less than 5 per Martian year. However, the local system dust storms, the local dust storms are more prevalent. I think they're usually called dust devils. And the point I wanted to make about that is before I forget it. Yes, the solar panels are affected by dust. However, it has been shown in several literature that um, it will reduce the output, the power output of solar panels, but it will not reach zero levels, because what the dust is doing is it's blocking the direct radiation. However, it's not blocking the scattered radiation. So it's the radiation is still there. And I'm just thinking of this at the top of my head, but I think it just reduces at the most the power output to 40%. So if we can couple the solar plant to let's say wind power plants, then I think it will balance the pros and cons of the two. Because one of the cons of wind, I think, is on Mars, is that the winds generated on Mars are not as strong as what we have on Earth. So we have to redesign to think of a way to make the turbines very adaptable to this kind of low velocity, low speed wind on Mars. So yes, there's that issue as well.
Awesome. Just to let everybody know, the next round of discussions is beginning right now. You can stick around here and ask Arvin more questions if you have more questions for him for about 10 more minutes. If you have time, Arvin.
Yeah, sure. I can get more.
But just wanted to let everybody know that they can be moving on to the next round of discussions if they would like to do that. We do have a question from Marco. He asks, are there other scalable forms of energy production that could be integrated with this system?
Yes. I'm just going to ignore for the sake of considering green energy. I'm just going to ignore the nuclear. But yes, there are already several, according to literature, there are already several scalable forms of energy production that we can apply on Mars. For example, as I mentioned, wind. And I think there's also aerothermal. It's like a geothermal but on Mars. But the issue with these other forms of energy is that we have yet to see them deployed on Mars. So yes, they are already mature on Earth, but in the context of Mars, it's very challenging adaptation. So for example, I just mentioned wind, and then for Mars, for the aerothermal implementation, just a quick point. On Earth, we tap for geothermal energy. We tap deep reservoir of stored energy and in the form of heat. But on Mars, we have yet to understand how hot is it inside, within the core or within the lower levels of the crust. And one implementation I've seen about this is that you want to tap the stored ice underneath the crust or the soil. And what you can do is let that gas sublimate from I don't know the correct word, but from ice to gas. You can use that conversion from ice to gas, because we all know that when carbon dioxide is released in the form of gas in a different temperature, then we can use that. You can heat that ice and then use that runaway effect to generate, you know, forward motion. But I'm just rambling about this. I haven't read much about aerothermal energy, but it's one of the possible implementations. Yeah, I hope I answered your question, Marco.
All right, yeah. So you're talking about energy of, what is it, higher energy of conversion or something like that, when
Mhm.
it changes phase?
Yes, the change phases from solid to gas. Yeah, solid to
Yeah.
gas, basically.
Yep, and sublimate is the correct word.
Yeah.
I don't see any other questions on here. Do any of our participants, we still have a few people in the room. Does anybody else have any questions for Arvin?
It's I can make a question or just writing.
You can talk, Professor.
Yeah, you can ask. Go ahead, Julio.
Yes, hello. I believe important issue would be the also consider the possibility of the use of the biodigester, because we can imagine the producing of sewage in the station, okay, in a future station, and then part of this composting process would be producing would produce energy to the station too.
Yes, that's a good point, Professor. By the way, I just want to give a quick shout out to Professor Julio. He's one of the authors of this study. Yes, that's also one way of looking of addressing the issue of power is there are some literature on uh, converting, using sewage to produce energy. And I mentioned this, I noted this in one of the slides earlier, but I didn't talk much about it because I think the technology is not that mature yet. However, there's potential because this will address this will create a closed loop in terms of the sewage and then energy problem, that we can use some of the sewage to create some amount of energy. I think we are already familiar with biomass here on Earth, and methane is one of the useful products of that process for energy conversion. Thank you, Professor, for that point.
Karsten, did you have a question? No. Anybody else?
Also, something that we need to think more about is related to the kilopower technology, and it's how much would be necessary to produce the energy to all entire station. Okay, it's just more a comment.
Thank you.
Thank you for that, Professor. Yes, kilopower is one. I think it's just being it's just popular right now because it carries so much energy in a small box, if you will. But in the long term, I think if it's just small scale, it will be an issue if we keep using kilopower. We have to find sources of uranium. I mean, there are sources of that on Mars, as mentioned in a previous presentation in this convention. But the problem with that, I think, on Mars would be how to set up the enrichment facility so that it can be utilized in the small. So I think in the long term, it will only benefit the bigger the bigger plants, but for smaller plants I think it's not very sustainable. Thank you for that, Professor.
All right, thank you very much, guys. If there are no other questions, we'll go ahead and let everybody move on to the next sessions.
Okay, thank you everyone for staying longer. I
Yep.
enjoyed the questions and the conversation.
Yeah, good answers, good discussion.
Thank you.
Congratulations, Arvin.
Thank you,
Congratulations.
Professor. Thank you to everyone.